Good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist. So today we're going to be doing another video here. Today's video is on how to use dimensional analysis worksheet number 2. All right, so a little bit of reading here, and you can kind of follow along, and hopefully you get the concept. And then we're going to do a set of problems. We have 13 problems, the very lucky number. 13 problems, because it is actually the lucky number, is number 13. So here we go, dimensional analysis. Dimensional analysis, known as the factor label method or the unit factor method, is a mathematical process of converting the units where the amount remains constant. Converting units is necessary such that comparisons of numbers can be done easily, especially if the numbers have the same set of units. This is accomplished by using unit factors or unit conversions, which are equivalent amounts with different units such that the units cancel in the mathematical process until the units of which are desired do not cancel. Number 1. Dimensional analysis is easily demonstrated with U.S. currency. The following are all unit factors, which again are equivalent amounts. A, 5 pennies is equal to 1 nickel. B, 2 nickels are equal to 1 dime. C, 5 nickels are equal to 1 quarter. D, 2 quarters are equal to 1 50-cent piece. E, 2 50-cent pieces are equal to $1. F, 4 quarters are equal to $1. I. There are many other conversions not mentioned above purposefully for this activity. And I'm going to slide this on up here, and we're going to do some examples here. Number 2, using the above conversions, one can convert from one set of coinage to another set as seen below. A. How many pennies are in 1 dime? You inherently know the answer, but follow the process. It's about the process, and that's what we're doing here, really and truly. Okay. 1 dime, and we're trying to figure out the number of pennies in 1 dime. So 1 dime is equal to, well, 1 dime and 2 nickels. This right here, I'm going to highlight it as what mentioned there above. This is a unit conversion right there. 1 dime equals 2 nickels. And you should see that the dimes in the units cancels out in the numerator and in the denominator. Perfecto. Then I have nickels. So how many how many nickels are in 1 dime? That would be 1 times 2 divided by 1. That would be 2 nickels. That is the correct. Now, then we're going to use another unit conversion. The next unit conversion is 1 nickel is equal to 5 pennies. And you should see that the nickels in the numerator and the nickels in the denominator, they cancel out, and then you're left with pennies. 1 nickel equals 5 pennies. So now what we're going to do is we're going to do the math. It says 1 times 2 times 5 divided by 1 divided by 1. That's equal to 10. And then there's my answer. 10 pennies is equal to 1 dime. Key concepts to understand in the above dimensional analysis problem. The units of dimes cancel. The units of nickels cancel. The units of pennies do not cancel. That's what you're looking for. 1 dime is equivalent to 10 pennies. That is, the amount has not changed, only the units have changed. We're going to do another example right here. Let's see if we can scroll this over. Yep, perfect. And let's see how far we can get on this. Oh yeah, we're going to be able to get it all. Get it all. What we like. All right, B, how many dollars are equivalent to 100,000 pennies? So we have 100,000 pennies. So if pennies are here in the numerator, then pennies must be in the denominator of this term. That way the units cancel out. 5 pennies is equal to 1 nickel. So what I'm going to highlight here in the yellow here, this is called a unit conversion. They are equivalencies. Then 1 nickel, so nickels are going to cancel out with nickels. This is also a unit conversion. 1 quarter is equal to 5 nickels. And then furthermore, a quarter will cancel out with quarters. And then you should see that now we have quarters to a 50-cent piece. So 2 quarters is equal to 1 50-cent piece. Then a 50-cent piece is equal to $1. The units cancel out on that. And you should see that $1 is equal to two 50-cent pieces. That is also a unit conversion. So you should see what I have highlighted in the yellow, the green, the orange, and the blue are all unit conversions. Those unit conversions are equivalencies, and those are very important. So now what we're going to do is say 100,000 pennies divided by 5 times 1 times 1 divided by 5 times 1 divided by 2 divided by 2 times 1. That equals 1,000. So 100,000 pennies is equal to 1,000 US dollars. Cool. Some key concepts to understand in the above dimensional analysis problem I. The units of pennies, nickels, quarters, 50 cents all cancel. I've shown that there. II. The same unit conversion has been used in example A and B of 1 nickel is equivalent to 5 pennies. But a key difference between the two examples is that the ratio is the reciprocal of the other in the two examples, see below. Right? In the first example, and I'll just slide that on up here so you can see it, that is, we have this 1 nickel equals 5 pennies. And so 1 nickel equals 5 pennies, and then 1 nickel equals 5 pennies. But one time the pennies are in the numerator, as is the first example, and the nickel is in the denominator. The second example, the nickel is in the numerator, and the pennies are in the denominator. But the number does stay with the units. That is, 5 pennies is equal to 1 nickel. That is essential in this whole process. All right. So it depends on the units that you start with, and what you end with will dictate how you cancel out the units. Okay. All right. Fantastic. Number 3, dimensional analysis is rather a simple process, but is dependent on precise canceling of units without skipping any steps along the way. And the key concept is that the beginning amount is exactly equal to the ending amount, only the units have changed, therefore the numeric value has subsequently changed as well. All right, now what we're going to do is we're going to do some examples. But before we do some examples, we have to thank our sponsor for today's video. And our sponsor for today's video is the Crazy Hat Chemist. And that is me. And I hope that you like and subscribe to this video. You know what to do with the like and the subscribe button. Please give it to me. I'd appreciate it. Tell your friends, tell your pet cat, etc. Tell everyone. Sorry for the bell there. Just a little recording here at school. So. All right, one of these days I'll be retired and I won't be recording at school anymore. All right, so here we go. What we're going to do is we're going to do some problems, but before we do some problems, we need to know some unit conversions. So we have some unit conversions here, unit conversions, and we have 2 different sets of unit conversions that we're going to be using here today. One is unit conversions of time, and the other one is unit conversions of distance. So we're going to take advantage of both of those, and we're going to be using both of those in all these problems. All right. So our first problem here is problem number 1, and it says, how many seconds are in 1 decade? So one of the key features here is that we are going to start with a number and start with units. That's how we're going to do this whole entire process. We're going to start with a number and a set of units. What is the number that we have in the problem? We have the number 1. And what are the units? It's a decade. And a decade is a unit of time. And so we're going to take advantage of this and work from here. So let's get another piece of paper and see what we can do and write this out. All right, so here we go. We're going to do problem number 1. Problem number 1. It says how many seconds are in 1 decade? I've highlighted 1 decade, so it's 1.00 decade. Okay, and so this is how this is going to work. I'm going to draw a vertical stop between this and the next term, and then I'm going to draw a horizontal line. I'm not sure how long I need to carry on this horizontal line, but we'll just start off with that right there. We're going to use some of the unit conversions over there, and what we have is a decade. What do we want? And so I'm going to highlight what we're looking for. It says how many seconds. That's what we're looking for. So we need to find a unit conversion that goes from decades to seconds. In order for this process to work, I'm going to have a decade. down here in the denominator and a vertical stop between that and the next term. So 1 decade is equal to 10 years. So years. So I'm going to use this unit conversion, 1 decade, 10 years. You can see that the decades cancel out. Do I have seconds yet? The answer is no. So therefore, consequently, whatever units are here in this numerator term, they need to cancel out with the denominator term next. So I'm going to have years. Vertical stop between that and the next term, and I'm going to say 1 year is equal to weeks. So 1 year has 52 weeks. Perfect. That will enable me to cancel out the units of years, and now I will have weeks within 1 decade. I'm not done yet because I want to end with seconds. So weeks needs to go here, a vertical stop, and 1 week has 7 days. 1 week and then days, and there are 7 days in 1 week. I'm going to cancel out the weeks, and now I have days within 1 decade. I'm still not done, so I'm going to continue my horizontal line here. Again, I didn't know how long I need to continue it, but whatever units are here in the numerator, they will go in the denominator of the next term. That's why they can cancel out. So days. 1 day has 24 hours. Hours. So 1 day, 24 hours. And now the days will cancel out. Now I will have hours within 1 decade. I don't want hours, I want seconds. So hours are here in the numerator. Hours must be in the denominator. So 1 hour is equal to minutes. So vertical stop. So 1 hour is equal to 60 minutes. Now you should see that the hours cancel out. I would have minutes in 1 decade. I'm almost done. Minutes to seconds. And I'm going to use this unit conversion of 1 minute is equal to 60 seconds. 1 minute is equal to 60 seconds. And now the minutes will cancel out. Now I will have the units of which I want, and the units of which I want are seconds. Okay, now I just need to pull out my calculator and type in all this information. So it's going to be 1 divided by 1 times 10 divided by 1 times 52, divided by 1 times 7, divided by 1 times 24, divided by 1 times 60, divided by 1 times 60 is again. And we're going to have a number, and then this is the number that's coming in my calculator. You can see it on both the upper and the lower level there. And I'll just write this down, okay, right here, and it will be let's see here. Let's see if we have enough space. Let's just slide this over just slightly. So this is going to equal 314,496,000, and that is seconds. There's our answer. That's perfect. All right, let's see if we can hammer out another problem. That is problem number 1. How many seconds in 1 decade? All right, problem number 2. Problem number 2. Let's slide this down, and it says how many weeks are in 1 millennium? 1 millennium. All right, 1 millennium. So again, what we're going to be doing is we're going to be using our unit conversions that are up above there. I'm going to slide this over here so I have a little bit more space in which to write all these answers here for you, and so that you can see this clearly. We're going to be using our unit conversions, okay? And so what we have is 1 millennium. And we're going to have a vertical stop between this and the next term. And I'm just going to carry this on here for the whole duration on this little piece of paper here. So you really get the full effect. There we go. So 1 millennium. All right. Now what we're going to do is we're going to use our unit conversions. So I'm going to tear out our unit conversions so that we have them nice and easily and simply. Here's our unit conversions. Those are the unit conversions that we're going to be using. And we are looking for how many weeks. So we're going to end with the weeks in 1 millennium. So if millennium is here in the numerator, millennium needs to be in the denominator and then a vertical stop. 1 millennium is equal to a century. So I'm going to have 1 millennium is equal to 10 centuries. We should see that the millennium units cancels out. Then centuries needs to be in the denominator here, a vertical stop. 1 century is equal to 10 decades. So 1 century, 10 decades. Okay, and then the centuries will cancel out, and then we are going to have decades. Decades, 2 years. Vertical stop, 1 decade is equal to 10 years. And then we are going to cancel out the units of decades. Then 1 year. And then 1 year is equal to weeks. And that's what we're going to end with. And there's 1 year is equal to 52 weeks. And then the years cancel out. And then we will have the units of weeks. So we're going to take in our calculator 1 times 10 divided by 1 times 10 divided by 1 times 10 divided by 1 times 52 divided by 1. So let's do that on the calculator. We're going to start off with that 1, and then it's times 10. And we're going to get 52,000. Our answer is 52,000 weeks. Perfecto. Awesome. Hopefully everybody's good with that. And let's continue on with the next problem here. What is the next problem? The next problem is number 3, and it says, how many seconds are in 10 decades? So I'm going to start off with the number and the formula of which are number units that I have, and then I'm looking for seconds in 10 decades. All right, perfect. So number 3, wait, that was number 2 right there. This is number 3. Number 3 is, I'm going to start off with 10 decades and vertical stop and a nice horizontal line here. Bingo. Perfect. And then I'm going to keep these unit conversions right up above so you can see those nice and clearly. And I want to end up with seconds after decades. So I need to have a decade here. And I'm at a decade, and that's 1 decade is equal to 10 years. Then years. I got the years, and I have weeks. 1 year, 52 weeks. Weeks and days. So 1 week, 7 days, and then days and hours. 1 day, 24 hours, and then hours and minutes. 1 hour, 60 minutes, and then minutes to seconds. 1 minute, 60 seconds. Decades cancel, years cancel, weeks cancel, days cancel, hours cancel, minutes cancel, and seconds do not. That's what I'm looking for. I'm going to multiply by all my numerator terms. So that's going to be 10 times 10 times 52 times 7 times 24 times 60 times 60 again. And I'm going to have a very large number, and this is going to equal 3.14 times 10 to the 9 seconds. It's like 3 billion seconds. That's a lot of seconds. All right, that's number 3. If we can do number 4. I know this seems kind of rather boring, but hopefully you're getting the point here. Number 4, it says how many centuries are in this large number of seconds. That's 1 times 10 to the 11 seconds. All right. Some might think that this is boring, but it's really just an entire process. So 1.0 times 10 to the 11 seconds. And a vertical stop, and then a horizontal section over here. And we're looking for centuries. So we need to end at centuries. So we're going to have seconds to minutes and a vertical stop. And for every 1 minute, there are 60 seconds, and then minutes. to hours. And there, for every 1 hour, there's 60 minutes. And then we're going to go from hours to days. 1 day, 24 hours, vertical stop. Then we have days, and we're going to go to weeks. So there are 7 days in 1 week. And then weeks to years. For every 1 year, there are 52 weeks. Years to decades. For every 1 decade, there are 10 years. And we got to continue this just a little bit more here. Decade to century. And for every 1 century, there are 10 decades. You should see that the seconds cancel, minutes cancel, hours cancel, days cancel, weeks cancel, years cancel, decades cancel. I'm left with centuries. So now what we're going to do is plug this into our calculator. It's 1.0 times 10 to the 11 seconds. We're going to divide by 60, divide by 60 again, divide by 24, divide by 7, divide by 52, divide by 10, and divide by 10 yet again. And we're going to end up with, I'm going to round this to a whole number, and that would be 32 centuries. That would be our answer. Perfect. Let's see if we can keep on doing and do a number of these. We have a whopping 13 of these to do, and hopefully these, if you actually do these will be very helpful for the stoichiometry portion that we will do eventually here. Number 5. Number 5 is the following. It says, how many centuries, that's what we're looking for, how many centuries are in 182,500 days? So 182,500 days, and I'm looking for centuries. So vertical stop and a horizontal line, and let's see how far we need to take this. Again, my unit conversions are right up above there, so you can reference those. I got days right here, and I am looking for centuries. So I'm going to go from days to centuries. So I'm going to go from days to weeks. So 1 week has 7 days, and then weeks to a year. And for every 1 year, there's 52 weeks. And then from years, I'm going to go to decade. And then for every 1 decade, there are 10 years. And then decade and century. For every 1 century, there are 10 decades. And again, the reason why we're doing it is so that the units cancel of days, weeks, years, decades, and I'm going to have centuries. So I'm going to take my 182,500, and I'm going to divide by 7, divide by 52, divide by 10, and divide by 10 again. And I'm going to have a whopping 5 centuries. That's our answer right there. Sweet. I'm going to slide this on up here so that we can do some more of these here. And our next problem is number 6. I know I'm trying to do this rather quickly here so that you can follow along at your own pace. And it says, how many seconds are in 50 years? So I'm going to start off with that number and units. So 50 years. I'm going to start off with 50 years. And I'm going to end with seconds. So vertical stop and a horizontal line. Horizontal line. So what goes down here? Years. And I am going to put my unit conversions right up here like that. And I want to end with seconds. So I have years. From years, I can go to weeks. So 1 year, 52 weeks, then weeks and days. 1 week, and there are 7 days. Days to hours. 1 day, 24 hours. Hours to minutes. 1 hour, 60 minutes, and then minutes to finally seconds. And 1 minute is 60 seconds. Again, the whole reason that we're doing this, years cancel, weeks cancel, days cancel, hours cancel, minutes cancel, and I'm left with seconds. Those are the units that I want. So it's going to be 50 times 52 times 7 times 24 times 60 times 60. And I'm going to get a very large number here for number 6. It's going to be 1.6 times 10 to the 9. 1.6 times 10 to the 9 seconds. What I got in my calculator here is that number right there that you see in your screen, and that is a rather large number. I put it in exponential notation for you, okay? You can watch another video on mine if you want to do those exponential notations. Okay, our next problem is number 7. Okay, fantastico. Number 7, it says, how many centuries, oh, sorry, how many centimeters in 1 mile? So now we're finally getting to another set of unit conversions, and those unit conversions are going to be distance unit conversions. So we're going to be using some distance unit conversions here this time. All right. So what do we have? We have 1 mile, vertical stop, and then a horizontal line. And what do we want? We want centimeters. So we have miles in the denominator, and then we're going to go yards. Vertical stop. 1 mile equals 1,760 yards. And we're trying to get to centimeters, so yards, 2 feet. 1 yard equals 3 feet. Oh, we might be able to do this a little bit differently here. Sorry, folks. 1 mile. We could do what we're doing there, but we're going to do another one here. And this will make more sense here for number 7 here. All right, let's give this a try. Mile and feet. I didn't recognize that. 1 mile equals 5,280 feet. And then feet and inches. 1 foot equals 12 inches, and then inches to centimeters. So 1 inch equals 2.54 centimeters, and then boom, I'm done. I'm going to see that the miles cancel, the feet cancel, the inches cancel. I'm left with centimeters. So let's get a numeric value for this. 5,280 times 12 times 2.54. And we are going to get how many centimeters? That is 160,000 centimeters in 1 mile. It's a lot of centimeters in a mile. All right, so let's continue on. We're going to do problem number 8. I'm going to pull this away so that we have some more sheets of paper to work with here. So number 8 is our next problem. And number 8 says the following. It says that we're looking for, what are we looking for? How many kilometers? How many kilometers are there in 10,000 yards? So we're going to start off with 10,000 yards, vertical stop, and we are looking for kilometers. So we're going to have our units of distance right here, and we are going to go from yards to kilometers. And so, let's see, we're going to go from yards to kilometers. So, yards to feet, and then feet to, let's see what we're going to do here. Okay, so this is what we're going to do. We're going to go from yards to feet. So yards to feet. And there's 1 yard, 3 feet. and then feet to inches. So there's 1 foot, 12 inches, inches to centimeters. And then there's 1 inch, 2.54 centimeters. Okay. And then we are going to go to, then we're going to go from 10 centimeters to 1 decimeter. And then there are 10 decimeters in 1 meter. Then we have one more to do here. And that is 1,000 meters, 1 kilometer. And then we're going to get our answer. So we're going to type this into our calculator here. And that is 10,000 yards times 3 times 12 times 2.54 divided by 10, divided by 10 again, and divided by 1,000. So we're going to have 9.144, 9.1 kilometers is equal to 10,000 yards. What a conversion. All right, fantastic. Let's see if we can do the next one. The next one is problem number 9. And problem number 9 says the following. We're looking for how many inches are in 1 light year. 1 light year. So how many inches in 1 light year? So we're going to put this right up here for our units, our unit conversions. And we are going to start off with 1 light year. Vertical stop. And let's do that horizontal line here that we are so desiring every single time. Okay, so we're going to have light year and then kilometers. 1 light year has 9.46 times 10 to the 12 kilometers. Then we're going to have kilometers to meters. 1 kilometer, 1,000 meters. And then we're going to have meters to decimeters. And 1 meter has 10 decimeters. And decimeters to centimeters. 1 decimeter, 10 centimeters. And we're looking for inches, so we can finally do that now. 2.54 centimeters equals 1 inch. And that would be light years cancels, kilometers cancels, meters cancels, decimeters cancels, centimeters cancels, and we're going to end up with inches. So in our calculator, we've got, what do we've got that we're going to do? It's a 1 times 1.46 times 10 to the 12 times 1,000 times 10 times 10 again, and then divided by 2.54. And we're going to get a very large number here for this one, for number 9. And it is 3.7. 3.7 times 10 to the 17 inches. That's a lot of inches. That's an immense amount of length distance. Okay, let's see if we can do this next problem right over here. Number 10. Okay, so number 10, what does number 10 say? It says how many kilometers are in 1 times 10 to the 4 inches? Okay, so we're going to start off with 1 times 10 to the 4 inches. And we want to get kilometers out of this here. So, all right, so we're going to have our unit conversions right up here. We want to get to kilometers, and we have inches. So inches, centimeters. So there's 1 inch, 2.54 centimeters. Centimeters to decimeter. 1 decimeter, 10 centimeters, and then decimeters to meters. So decimeter to meters, and there's 1 meter and 10 decimeter, and now looking for kilometers. So 1,000 meters is equal to 1 kilometer. Bingo. Inches cancel, centimeters cancel, decimeters cancel, meters cancel, and then we're left with kilometers. So that is 1 times 10 to the 4 inches, 2.54 multiplied, divided by 10, divided by 10, and divided by 1,000. And we're going to get 0.254 kilometers is equal to 1 times 10 to the 4 inches. No way. Unbelievable. All right, now what we're going to do is we are going to do the next problem. We're going to do problem number 11. Problem number 11. Problem number 11 is the following. How many seconds in 1 millennium? Oh my gosh, now we are on a time. Again, we're on another unit conversion set, which is time this time, pun intended. So what do we have? 1 millennium. And we want to get to seconds. So this is going to be a very long one. So let's see if I can fit this in this space here that we have. All right, let's see if we can do this. Let's see if we can fit this on a sheet of paper. Okay, so we want seconds from millennium. So we're going to go through this entire piece of paper here effectively. 1 millennium, and that's equal to 10 centuries. And then 1 century, that's equal to 10 decades. And then 1 decade is equal to 10 years. And then 1 year is equal to 52 weeks. And then 1 week is equal to 7 days. 1 day is equal to 24 hours. And let's see if we can fit this in, folks, on a whole sheet of paper. 1 hour is equal to 60 minutes, and 1 minute is equal to 60 seconds. All right, we did it. Millennium cancels, century cancels, decades cancels, years cancels, weeks cancels, days cancels, hours cancels, minutes cancels, and we're left with seconds. And here we go. It's 1 times 10 times 10 times 10 times 52 times 7 times 24 times 60 times 60. And then we're going to put this in exponential notation because otherwise it's just crazy. 3.1 times 10 to the 10 seconds. So 1 millennium has 3.1 times 10 to the 10 seconds. Oh, holy moly. Check it out. All right, let's do 2 more problems here. And you are waiting for the very last problem because the very last problem is actually the best and the most important. Number 12. It says the Earth is 25,800 light years away from the center of our galaxy, the Milky Way. How many feet is this? So what do I have? I have 25,800 light years, and I am looking for how many feet. That's what I'm looking for. So let's start off here with this number and units. So 25,800 light years. And I'm looking for feet. This looks like this one might be a long one as well. And this is a distance conversion here. So let's see if we can hammer this one out. So light years needs to be down here. And 1 light year has 9.46 times 10 to the 12 kilometers. And then 1 kilometer is equal to 1,000 meters. And then what we need to do is 1 meter is equal to 10 decimeters. And then 1 decimeter is equal to 10 centimeters. 2.54 centimeters is equal to 1 inch. And finally, 12 inches is equal to 1 foot. And then we will have how many feet are in the distance between the Earth and the center of our galaxy, the Milky Way. No way. So this is 25,800 times 9.46 times 10 to the 12 times 1,000 times 10 times 10 divided by 2.54 divided by 12. This is a very large number. This is 8.0 times 10 to the 20 feet. So what is the distance between the Earth and the center of our galaxy in feet? It's 8.0 times 10 to the 20 feet. Oh, holy moly. Can you believe that? I can't believe that. All right, let's do our final problem. And you are all waiting for this final problem. This is actually the best problem of the whole entire lot here. Okay, and that problem is the following. Number 13, if you are traveling at 65 miles per hour on the highway, so if you are traveling at 65 miles per hour on the highway, how many feet do you travel per second? How many feet do you travel per second? Now, this is a two-part problem. We are going to be using units that are for distance and for time in the same problem. So that's why this problem is the problem that is so exciting. Okay, well, at least it's exciting to me, and it does have some really good information here for you as well. Okay, so some really good thought information for you drivers. So we have 65 miles per hour. For how many hours? 1 hour. And I want to figure out how many feet we travel per second. So what we're going to do is we're going to take care of our numerator and cross out these units for the numerator. And that will be miles. Now that is actually a distance. So I want to get these miles into feet, right? So I'm going to travel how many feet per second? So I'm going to go from miles to feet. So 1 mile is equal to 5,280 feet. And you should see that the miles cancels out. Okay, so I'm going to see how many feet we travel per second. Now, hours are here in the numerator, so I'm going to have hours over here. That's a unit of time, and I'm going to go from hours to minutes. 1 hour, 60 minutes. The hours cancel, and then I'm going to go from minutes to seconds. 1 minute, 60 seconds. And you should see that right here that the minutes cancel, the hours cancel, and then the miles cancel. And you are left with feet. Let's highlight this. Feet per second. So let's plug this into our calculator and see what we get for a numeric value. That's 65 times 5,280 divided by 60, divided by 60 again, and we get this answer, 95 feet per 1 second. Let's roll this on up here. So that means the following. So I want you to think about this here. If you are a driver of an automobile, if you are traveling at 65 miles per hour, How many feet do you travel per second? 95. So if you look down to turn on your radio, to look at your phone for 1 second, you have traveled 95 feet. In that amount of time, you have just traveled 95 feet in 1 second, and you don't know what you've traveled over. If you look down to turn on the radio, to turn off the radio, to change the station, if you look at your phone for 1 second, you have traveled 95 feet if you are traveling at 65 miles per hour. Just think about how many feet you have traveled um, in 2 seconds. That would be 190 feet, right? Just think about how many feet you would travel in 3 seconds. You will have traveled 286 feet in 3 seconds. That's amazing. This wasn't the most exciting video of them all, certainly not, but hopefully you have some better ideas of unit conversions. I hope you have a fantastic day. I'll see you next time. Bye for now.